Hello, this is Math Jazz from Almost Cool. Today, our live stream is going to talk a little bit more about probability and statistics. And so, let us get to the problems that we will do today. Oh, and by the way, if you have any questions, please put them in chat or email them to me, and I will answer them as we go through the live stream. So, yeah, with that, let's move on to some problems. So today we're going to be talking about means, medians, modes, frequency distributions. We're going to talk about range, variance, and standard deviation. We'll see how many of these we get through in about half an hour, more if we have questions to answer. So let's see. So the first thing we want to talk about are going to be frequency distributions. So we're going to give this term here, frequency distribution, is going to be our term for the relationship, the number of occurrences that a particular trait has in a population. So for example, I have this problem here from the textbook that my class is using. It's called Finite Mathematics, and it's by Margaret Lyle. So this is a problem taken from that. But the situation in this example is we have some business executives that are being asked questions about how many credits students should take in certain fields to be prepared to become members of their corporations. So it says that 30 business executives were asked for their recommendations as to the number of college credits in management that a business major should have. Okay, and their answers were as follows. So we're going to write out this table. So there are 30 of these, so it's going to take me 3 times as long as that first row took to get all of these down. And to check that I'm centered. So these are the numbers that we're looking at. Now to restate this, there were 30 business executives asked the question, how many credits in management should a business major have? And these were their answers. So these are the results from the sample population. Certainly there are more than 30 business executives that exist in the world, but our population of business executives, we've selected 30 of them to be our sample. Our sample size is 30. And the frequency distribution of this sample is going to be, well, for example, it looks like there are 2 people that said 3 hours of management classes. Oh, this is a little wider than I thought. Let's pull back a little bit. Okay, so there are, say, 2 3s in the data set, so the frequency of 3 is 2, and the frequency of 9 looks like it's also 2. And so if we just kind of sort all of these 30 results into what the response was and how many times people said it, we would get what's called the frequency distribution. So, for example, it looks like there are, oh, there's an 8. Because 8 comes between 3 and 9, so it should have been between our 3 and 9. But I'm not going to write out the whole frequency distribution. Frequency distribution is the term that says, once we've had all of our responses sorted, we have some sort of graph where this axis is the response, or the whatever trait we're measuring, and this axis represents how many times a response came up. So the frequency of the response. That's what we mean by our frequency distribution. It's going to be the relationship between what a response was and how many times it appeared. Okay, so I think that once we have that terminology down, well, that's not so hard to do. We won't actually graph the frequency distribution of this. However, what we will do is we'll start talking about other things about the frequency distribution. There are several traits that a frequency distribution can have. The first of which that we're going to talk about is the range. This is probably the easiest thing to find. So the range of a probability distribution is the distance between the highest value on the distribution and the lowest value. So we'll do a little bit of fishing in our table, and we'll find out what that is. So, to me, looking at this frequency distribution, it looks like 3 is the lowest value on this distribution. I certainly don't see anything less than it. And if you in chat see anything, then please tell me, because I'm just going to go on as if 3 is the smallest. And then looking up here, I see a 25, I see a 34. 34 is probably the largest value in this distribution. So looks like our low is a 3, and our high is a 34, which means that our range is going to be 31. That is, 34 is our highest value minus 3 is our lowest value. That gives us 31 as our range. So the range tells us when we have some sort of frequency distribution, the distance between the lowest and highest point. And that's an important thing. That tells us something about the shape of our distribution. So it doesn't tell us a lot about our distribution, but it does tell us something. And we're going to continue to add more different traits that we can study. I think that the next one we should talk about is probably the average. So this is our frequency distribution, and we're going to find the average of it. So the average is a term that usually means the arithmetic mean. And that's what I'm going to take it to mean here. Also, could just mean the mean. So there's something called a geometric mean, but we're not going to talk about that in the live stream, except to say that there's such a thing as a geometric mean, and it's different from the arithmetic mean. So I'm going to use the term mean and average and arithmetic mean interchangeably. I'll probably stick with use average. I'll want to use mean, but I'll probably use average a few times. These three things, when I say any one of these things, I'm going to mean the other two as well. So the definition is the average, which we usually denote with a little bar on top of our random variable x, is equal to the sum, that sigma means sum, of all of our expected values of x, or all of our allowed values of x, divided by the number of x's we have. So in our case here, with this distribution, we have 30 numbers here. Those are our x's in our definition. Those are these x's, and we're going to add all of them together. So that's going to be 3 plus, there's a second 3, there's an 8, there are actually 2 of them, now that I look, and then 2 9s, I'm adding them. And we go all the way up to our highest value, which is going to be 34. Actually doesn't matter in what order you add them, because addition is a commutative binary operation, meaning that you can swap the order of things and it doesn't change the value. And then we're going to divide by 30, which is the number of numbers in our distribution. So, in our sample set. So, with that, let us swap over to something that can handle way more calculations than we can handle by hand. So, here we go. So, I have my sample set is going to equal, maybe I should go sample, and we will type in our numbers. So we have 3, 25, 22, 16, 0. There we go. Here is our sample set. The semicolon means that when I execute this line of code, it will not return anything back to me that I didn't ask for. So now when I type in sample, did I have a capital sample? I did. I meant a lowercase one. There we go. So now when I type sample, I get out my list of numbers, and they're kind of small, but that's fine. So this, whenever I type sample, because I've taken this group of numbers and stuck them in a box that I labeled sample, I now have it available as I need to. So if I want to find the average, what I'm going to do is I'm going to add up all of the values in my sample. So I want my average, I'm just going to call it av. That's going to equal the sum of the stuff in my sample and I want to add up from the first element of the sample, is the first element, up to the 30th element, and I'm going to divide my sum by 30. So this is what this code does. Let me pull it up here. So I have my average is equal to sum of, here's sample, it's going to pull the ith element out of that. where I is going to range from 1 to 30. So I'm going to pull out the first element, and then the second element, add it to the first element, and then the third element, add it to the first and second element, and so on, until I add up all 30 elements together, and then I'm going to divide by 30. So once I hit the execute key, I get this number, which I'll make bigger for you, 239 over 15. So I suppose that after it canceled the 2 from the 30 in the denominator, 239 is half of what the sum is. I actually want this to evaluate all the way to a decimal, so I'm going to put an n and square brackets around everything. And by doing that, it will actually execute the code and give me a decimal number, which I will make larger for you so that you can see it. There we go. So it got 15.93 repeating. And this change has to do with the execution of the code. But this is the number that we got, 15.93. And that there is our average. It is the sum of all of the values in our sample divided by the number of values in the sample. So what does the average tell us? Well, the average, it kind of gives us an idea of the center of our distribution. So we look at our distribution again. We notice that the high values are in the high 20s and low 30s. The low values are 0 and 3 and single digit numbers. And so if we were to graph all of our values, then we should get some curve that is somehow kind of weighted towards about 15 or 16. You can pull up our Mathematica again. Let us plot our sample. So if I do a list plot sample and then execute the code, I get this graph here. This graph represents all of the data that we have in our set. Well, let me sort this first. Sort a command? Yeah, sort is a command. There we go. So these are all of our values. So this is actually also not the graph that we want. It's called a frequency plot. Nope. Well, I don't know the Mathematica command offhand to make a frequency distribution, and I'm not going to make you wait for me to find it. But I'll probably have the video on Thursday. We'll have a frequency distribution graph. Okay, so, but this is the kind of idea graphically of what a frequency distribution would look like with its average placed on it. So let's say we have some frequency distribution that looks maybe like this. The average will be something like this, where what's happened is that objects in the frequency distribution that are really high have kind of pulled the average from this bump a little bit to the right, and it represents kind of Well, physically, if I were to take this graph and make a shape that was a flat shape, kind of like a plate that when I looked on it, it looked this shape here, then the average will be the place that it balances. So if I have a plate that's a circle, the average would be here, and the plate would balance on this line. And with this frequency distribution, if I had a plate that looked like this, then I could take a rope and I could lay the plate so that the average line was on that rope and it would balance. That's what an average does kind of physically, is it gives us the idea of where the center of the distribution might be. So that's one way of thinking about it, is that the average is kind of the center of the distribution, the middle. But the average and the range are not the only two measures we have for the shape of a distribution. The next thing that we're going to talk about is called the median. So we have our median, and the median is the middle entry in our distribution, the middle value. And if that doesn't sound well defined, well, this is what I mean by it. If you take all of the elements in your distribution and you put them in order from lowest to highest, so in this case we have 0, 3, 3, 8, 8, 9, 9, and a bunch of stuff, and 34 as the highest. Whichever element is in the middle, that's the median. And if you have an even number of elements, then you take the average of the middle two. So here is a median of a 5-element set. So let's say we have 2, 7, 7, 8, 9, 11, 12. Here's a set of numbers. So this is an odd number of elements for our sample size. The middle one is this one, because there are 1, 2, 3, 4, 5, 6, 7, and so the fourth element is the one that is in the middle. That is the median of that set. Now, if we have another set that has 6 elements, so it's an even number, here it is. Here's a 6-element set. Well, you can't pick the middle element in an even number of elements, so that means that what we have to do is we have to take the 2 middle elements here, 5 and 7, and usually we average these. So 5 and 7's average, well, the average is computed as the sum of our values divided by the number of them. That would equal 12 over 2, or 6. So this is our median for this set of values. Now, let's get back to the set of numbers that we said at the beginning of the video. That is, of course, this group of numbers, and we will find the median of that. So, going back to our computer, that's this button. We can sort these sample. So I'm going to sort the sample, and that gives us our list. Here we go. And now there are 30 elements in this list. So we count 1, 2, 3, 4, 5. There's 10. There's 14 of the elements. So this is the 15th element here. This is 15, and this is the 16th element. It's interesting that they are both 15 and 16, but those are the middle two elements in our set. And we take the average of those two elements, getting 15 and a half as our mode. And I think that, yeah, we can compute the mode of the sample and we'll see what happens. Oh, maybe it doesn't like that. Oh well. Oh, sorry, I was calculating the median. The median is the middle element, or the average of the middle two elements. But mode is the next thing that we're going to learn. So let us switch over to our paper to talk about modes. So the mode is the element in our sample that appears the most often. Okay, so for example, in these two small sets, the mode of our first distribution is 7, because 7 occurs twice and everything else occurs once. And in the other small distribution, the mode is still 7, because 7 appears twice and everything else appears once. The mode doesn't have to be 7 on every set. Looking at this, we can actually do this one without looking at Mathematica at all. We'll figure out what element here appears the most often. Well, let's see. There are 2 9s, so that could be a mode. There are 2 16s. There are 2 15s. Is there anything that occurs more than that? 2 14s and 2 12s. Ah, there are 3 12s. 1, 2, 3 12s. So now we have to beat 3 of something to have a mode. There are only 2 3s, only 1 0, and the 134, only 2 8s. Yeah, I believe that we found our mode. Our mode is 12 because we have 3 12s show up and only 2 of anything else. Only 1 or 2 of anything else. So, our mode on our large distribution is 12. So, what does that mean for the shape of a graph? Well, if you have a distribution that's like this, then your mean might be over here, and your median might be over here, and your mode is going to be this peak. So the mode is the most often occurring value. The median is the value that that's in the middle of everything, and the average is well, it's the expected value of your distribution. If you randomly picked something, then the expected value is kind of, well, physically, as I said, it's the balance point of the distribution. If you were to make a physical object in the shape of the distribution, it would balance on the average. So it's the average. This is the median. And this is the mode. So on a weirder looking distribution, let's say we have something that looks something like this. Okay? So this is going to be the mode. The average is going to be pulled significantly up here because of all of the weight that's high up from the mode. The average is also called the mean, so I'm going to try and use that term. And the median will also be pulled up from the mode because there are lots of elements up here to, we're trying to find the middle element for the mode. And this, sorry, for the median. So it'll be higher than the mode in this case. Well, what happens if you have an object that occurs if you have two or more objects that occur at the same frequency and they all tie for most, well, then you can have something that's called bimodal or trimodal. So here is my trimodal distribution. We have 3 modes because they all occur equally, but they all occur more than anything else. This is kind of how grades distribute themselves in a class. You'll have an A cluster and a B cluster and a C cluster, usually. Or I don't know how that is in other classes, but that's how it typically happens in the math classes that I've taught. So you'll get these clusters. Anyway, so this is a trimodal distribution. This distribution looks like it is going to be skewed higher than, so the average will be over here because, let's make that more obvious, because the graph of this comes down to 0 on this end and it continues on being non-zero up there. So this will be our median, or sorry, our mean. We pulled up because of the weight up here. And our mode, well, we have 3 modes, and our median is going to be the halfway point, which is going to be somewhere like this. This is our median, our middle value. Great. Okay, so let's see. Oh, it looks like we are actually out of time for the day, but we're going to talk about variance and standard deviation on Thursday, and of course any questions that are emailed to me in the interim, we will also get to those. So we will see you all next time on Thursday. Come with all of your questions and we will get through those, and we'll talk about variance and standard deviation. Have a great day. Hope you're enjoying learning more about math and probability and statistics. Bye!